Today we're going to do lesson 5.1, and while we do 5.1, we're actually going to include 4.7 and 4.8. We're just going to touch on those lessons and then continue on to 5.1. While we do this, I need somebody to raise your hand and tell me, what is slope-intercept form? Who can tell me what slope-intercept form is? Naeem? Very good. Y equals mx plus b. Okay, you guys, I want you to go ahead and write that down. Y equals mx plus b. I want you to write that down because we're going to notice something about the questions that we have, or the examples that we have in this problem here. Look at the first and second problem, the only two problems on the page. What are they missing that our slope-intercept equation has? Josiah? Y. The y. Neither of these equations have a y in them. So we have to ask ourselves, they want me to put the equation in slope-intercept form, but how do I do that when there is no y? This is all you have to do. It's actually very simple. When we are working with graphing, there is always a number that can be interchanged with y, and that number is 0. Anytime I have a 0 in my equation, I can swap it out with the y. It does not work for any other letter, and it only works when we are graphing, okay? So in order to add in a y here, all I need to do is get one side equal to 0. You guys are good at that. We've been doing this for a while, moving things from one side to the other. What could I move to get a 0 on one side? What do you see that's over by itself that needs to be moved to the other side? 13, I heard it, okay? 13. We can move 13 because does it have a like term on the other side to combine with? Yeah, we can combine it with 6, and then what am I going to be left with on that side? Nothing, or a 0. Perfect. That's exactly what I want. At no other times do you ever want a 0, because remember I've always said, no, we have nothing left. We cannot do that. That's when we're solving equations. So we minus 13, which cancels out, and we minus 13. Make sure you only subtract 13 from its like term, because we could not subtract 13 from 4x because they're not like terms. So now I have 6 minus 13 is negative 7 minus 4x equals 0. Now the rule I just told you was anytime I see a 0, I can replace it with a what? A y. So let's rewrite this. Or actually, I'm just going to erase the 0 and replace it with a y. Now here's my question to you. Does this equation right here look like our slope-intercept form? No. It has all the correct pieces, but it's not in the right order. So let's just rewrite it in the correct order, because technically I've got everything where it needs to go. It just needs to be kind of switched around a little bit. So let's write y equals out front, and then of my negative 7 and negative 4x, what has to come first? Negative 4x. And then I can just write minus 7. Now does this look like y equals mx plus b form? Yes, it does. This is your answer right here. That's all they want you to do is write the equation, because now what you would be able to do is you would be able to graph it. And in lesson 4.7, they do ask you to graph it, but because we just graphed in 4.6, we're going to skip over that part. Okay? So let's do the next one. Again, in order to get a y in my equation, because I see that is what I'm missing, I've got to get one side equal to 0. And in this equation, there is 2 terms on both sides. So, here's your choice. We can either move these 2 to combine on this side, or we can move these 2 to combine on this side. You will get the same answer either way. I am going to do these to combine over here, because in that way it's already in y equals mx plus b form. I don't have to worry about switching anything around. So I'm going to say, okay, in order to move the negative 4x to combine with a 3x, what do I need to do? Add 4x. Cancels out here, and I add 4x. Now in the same step, I'm going to go ahead and move the 5. Just, it saves me a little bit of time. So what do I need to do to move the negative 5? Add 5. Cancels out here. I add it here. Does everybody see how I did that in one step? So now what am I left with on that left side? 0 or nothing. 3x plus 4x is 7x. 8 plus 5 is 13. The only thing I have left to do is what, Josh Center?
I got this, Mr. Rubin.
Jared?
All right, you're gonna say y equals 7x plus 13.
Very good. All I do is take out the 0 and replace it with y. And is this equation in slope-intercept form? Is everything in the right order? Yes, it is. So I know that this is my answer. Okay, that's how we take an equation and put it in slope-intercept form when I'm missing a y. So the next example is a very quick representation of lesson 4.8, which is all about functions. So I want everybody to get out your books and look at page 259. Everybody open up your books and look at page 259 for this first problem. On page 259, we see 3 problems here that they're asking us, does the relation represent a function? Okay? We learned about this back in chapter 1. It was actually one of the first lessons that we did. Does the relation represent a function? Who can tell me what is the definition of a function? Who can raise your hand and tell me what is the definition of a function? You got to pull way back. Anybody remember, Josiah? That's function form. Okay, so Michaela, what was the definition of a function?
For every input, there's only one output.
For every input, there is only one output. Very good. Okay, so look at those problems in your book. In order for this to be a function, for the input, it can only have one output. So look at number 14. Is that a function? Yes, because look at the 1. It has one arrow drawing to the 2, or I'm sorry, to the 5. So we know it is one output. Same thing for every single number. They only have one arrow going out, so we know it's a function. Look at number 15. This is the one that people get confused on. Is number 15 a function? Yes, because for the input of 1, it only has one output. It's only got one arrow going out, and it's to 0. For the input of 2, it's only got one arrow going out, and it is to 0. It's one output. Same thing for all the numbers. They only have one output. It all happens to be the same number, but that does not matter. But look at number 16. Is number 16 a function? No. Why not?
Number 10 has 2 outputs.
For the input of 10, it has 2 different outputs. It has 2 arrows coming out, and it has an output of 8 and an output of 10. So it is not a function. Now, you have to know on your test and quiz why it is or is not a function. So if it is a function, the definition you would write is, for every input, there is only one output. If it is not a function, like for example, number 16, we would say, because the input of 10 has 2 outputs, it is not a function, okay? So on example 2 here, evaluate the function when x is equal to 2, 0, and negative 3. First of all, this is something you guys have never seen before, but it will be a lot in Algebra 2 and trigonometry. This type of equation right here is what we call function notation. You say, wait a second, I thought function form meant y by itself. Yes, technically. But this is what we call function notation. We would read this as f of x. Basically, we're saying for the function of x, that tells me that for one input, there's only one output. This is what I'm going to get. It looks confusing, but it's actually very, very simple. We would do this like we would do any other problem that we did at the beginning of the year. I want to evaluate this problem when x is equal to 2. So everywhere I see an x, I'm going to plug in a 2. So let me do that. Let's write that down. F of 2, because I see an x there, equals 10 times 2 plus 1. Now here's the thing about this problem. The f of 2 is not an actual part of the problem that you will be solving. This f of 2 will stay all the way down because basically we're saying for the input of 2, this is what I get as my answer. So it would be the same as if it was a y or any other letter that is not part of the equation. So we're only solving this side right here. So what's 10 times 2? 20. And then I would say for the function of 2, I have 20 plus 1, which is 21. So here's the part about it that makes it a function. Watch this. For the input of 2, I get an output of 21. There's only one output for this input. Does that make sense? Yeah. So that's all we're doing there. So let's do the same thing but with 0 and negative 3 because they want me to evaluate for all kinds of different numbers. So we're going to say for the input of 0 or f of 0 equals 10 times 0 plus 1. What would I do first, JT?
Well, you do 10 times 0,
Which is 0. So I get 0 plus 1. And then what would I do, JT? Okay. For the function of 0, 0 plus 1 equals 1. So f of 0 equals 1. So far, these are my two answers. And last but not least, we need to plug in a negative 3. So we're going to say for the function of negative 3, I get 10 times negative 3 plus 1. Dion, what am I going to do first?
Right now.
Mm-hmm.
Isn't that negative 20?
I want you to tell me what I should solve first. 10 times negative 3 is? Negative 30. Very good. So for the function of negative 3, negative 30 plus 1 is what? Negative 29. Okay? These are my three answers here. So now what we're going to do in example 3 and 4 and 5 actually is we're going to get into lesson 5.1. We're going to go back to slope-intercept form. Again, who can tell me what slope-intercept form is? Y equals mx plus b. You guys have got to memorize that. That will be on your test. It will be on your quiz. You'll have to write it out. That's an actual question. Write the equation. And then there's going to be a lot of different questions where you have to use that equation. So if you don't know it, you're going to be out of luck. Here's the best thing about these examples is in order to write an equation in slope-intercept form, there's two things I need to know. I need to know m and I need to know b. Remember, x and y in slope-intercept form always stays x and y. We're not plugging any numbers in for the final answer. We just need an m and a b. So let's read what this equation says. Write an equation of a line. Basically, that just means slope-intercept form because that equation represents a line, whose slope m is negative 2. So let's write that down. M equals negative 2. And whose y-intercept b is 5. So let's write that down. B equals 5. I just told you, what are the only two things I need to know to write an equation in slope-intercept form? M and b. Do I know m and b? Yeah. So let's just write our equation and plug in the numbers. Y equals m. What was my m? Negative 2x plus, what's my b? 5. There's your equation. That's all they want you to do.
Why don't they just call B Y? Why don't they say Y?
The y-intercept is never represented by the y because we want to be able to plug in an additional point like x, y. That's why we leave those blank so that if maybe I'm missing my slope or maybe I'm missing my y-intercept, I can always use a point to find it. So B, I'm not exactly sure why they chose that specific letter, but they would never do y because that represents an ordered pair, not necessarily just the y-intercept. Okay, let's do this next one. Read it. Write an equation of a line whose slope m is what? 3/4. And whose b is what? Negative 4. Now, here's the tricky part. Well, it's not really tricky. I just want to make sure you don't get confused. Slope-intercept form is y equals mx plus b. But what is my b in this equation? A negative. So I can write it as y equals 3/4 x minus 4. It does not have to have a plus sign there. If your b or your y-intercept is negative, we write it as minus whatever the number is. If you wanted to put plus -4, you technically can. It's just not needed. That positive or that plus sign does not do anything for our equation. So it's just like an extra piece in there. So this is your final answer here. So we used slope-intercept form to write an equation when I have m and I have b. Those are two things that I have to know. So now what they're going to do is they're going to give us a graph. This graph would be given to you on your homework, on your quiz, on your test, and they want you to use, or they want you to write an equation in slope-intercept form. We just went over, what are the only two things I need to know to write an equation in slope-intercept form? M and B. I can find out M and B by just looking at this graph. It's actually very simple. M and B. Earlier, I asked one of you, what is the y-intercept? And that was an important question because you've got to actually know what it is in order to be able to locate it on that graph. So somebody tell me again, what is the y-intercept, Josiah? Where the line crosses my y-axis. So let's put a point there. Let's say my line crosses the y-axis where? At -1, right here. So we know that my y-intercept, or my b, is -1. Let's write that out. So we know that my b is -1. But now we've got to find our slope. And slope is always a fraction that is what? What over what? Carter? Rise over run. Very good. So what I can do is I can go from my y-intercept to the next point on the graph. And what I mean by next point on the graph is where it crosses two whole numbers. So technically I would follow the line. I would say, oh, is this a point? Well, yeah, it technically is, but it's not going to be a whole number. So let's keep going. So for this example right here, they want us to write an equation of the line, but they did not tell us M and they did not tell us B, but they did give us a graph. So what I'm going to have to do is I'm going to have to locate on this graph my y-intercept, and from that y-intercept, I'm going to find my slope. So M, I've got to find, and B, I've got to find. Remember, in the last example, we said, what are the only two things you need to know to write an equation in slope-intercept? It's M and B. So we know that our B is where our line crosses the y-axis because it's our y-intercept. So I look at this line right here, and it crosses the y-axis at -1. So I know that my B is -1. Now from that y-intercept, I'm going to use my slope to go to the next point. I look on the line, and the next point on the line is -2. So I'm going to use my slope, which I know is rise over run, to get to that -2. So I'm going to go up 1. So that means my rise is a +1. And then I'm going to go over 2. But in which direction did I go over? That would be negative. So it's going to be over -2. So in order to write my equation in slope-intercept, it's going to be y equals -1/2 -1/2 x minus 1. So that's how we would use a graph to write an equation. Now, in these type of problems, they will always go ahead and give you the graph. It's not something that you're going to have to do on your own. They will give you the graph, and that's what you're going to use to look at it. So then in the next example, they want us to do the exact same thing. So let's locate our y-intercept. I look at my line where it crosses the y-axis, and I see that it is at -4. So I know my B is -4. And then I need to use my slope to go to the next point. Well, I've got a couple different options here. Here is technically my next point. Or I could go all the way up to what we would call the x-intercept. Or technically, I could go down. if you go from the y-intercept to any one of these points, you will always get the same slope. Because if I went to this first point right above it, I'd go up 2. So my rise is positive 2, and over to the positive 1. What if I went from my y-intercept to the next point? I would go up 4 and over 2, which is technically 4 over 2, which is 2. Or I could go down 2, which is a negative 2, and over negative 1, which is technically 2. So does everybody see how it does not matter from which point you go to the next point, you should always get the same slope. So what I would do now is I would write my equation in slope-intercept form, which is y equals 2x minus 4.